Hey, hi everyone. Thank you once again for joining. So, welcome to today's webinar. Thank you so much for taking the time to join us. So, as AI agents becoming, increasingly popular and deployed in real-world applications, ensuring they perform reliably is more important than ever. So, in today's session, our speaker will explore everything in detail. So, coming to our webinar speaker, Revraj is a full-time, full-stack software engineer with 6 years of experience building and delivering software applications. So, he is passionate about automation, AI-powered workflows, and is an active participant in tech events and developer communities. So, excited to have him with us today to share his insights on AI agents. So before I hand it over to Yuvraj, a quick note to you folks. We'll be having a Q&A session at the end of the webinar. So if you're having any questions during the session, please drop them in Q&A panel. So Yuvraj will take it up and address them at the end. With that, over to you, Yuvraj. You can start the session.
Yeah, thanks for the introduction, Pichandal. Hello, everyone. I hope you're doing well. Yeah, let me share my screen. I hope my screen is visible. Yeah, so today we will be looking at testing AI agents. So let me give a quick introduction about myself. So I've been a full stack engineer for 6 years, and most of my career I've always found processes to be my sort of thing. Um, Starting from my first year, I've always wanted to, build correct processes so that things are done properly. When it comes to AI in particular today, we want to move fast, we want to break things fast, but that also means that there's not really a process that everybody follows. So that's where my passion about this came about, and that's what we'll be talking about. We'll set a process that your team can follow and that you can take back to your stakeholders and give them the confidence to ship properly, right? So we will be using LangGraph and LangSmith for this to evaluate our pipeline and to build our AI agent pipeline. We'll get into it. Yeah. Yeah. So before that, I want to have a quick poll. How do you all currently test your AI agent pipelines? Do you do this manually, or do you have some sort of automation, or you don't have any process for it? Uh, Give your answers in the poll, and yeah. Right. So I see a couple of responses, and some say fully manual and yeah, partially automated. Yeah, that seems to be the trend. Most of the folks have a few set processes where they go and spot check things for their AI pipeline, and some have a very rudimentary partial automation to test this. But today, what we'll see is how to like have a full eval suite that you can rely back on, that you can ship with confidence. We will look at giving you a score that you can base your confidence on. Right. Yeah. So this will be our agenda for today. We'll look on why evals matter in the first place, and we will build out a translation agent, an AI translation agent. So this will be our demo problem for today, and then we'll move on to observability with LangSmith, and we will then go on to offline evaluation techniques like human LLM and code, and we'll combine these with a composite score. And after that, we will see how you can iterate very confidently with that score that we got from the previous step. And in the end, we'll look at online evaluation and real-time monitoring and then wrap it up. Yeah. Feel free to ask me any questions anytime you have them. Right. Yeah. So we'll look at why evals matter. As we all know, LLMs are stochastic, right? Which means that whatever whatever change that you do may not exactly be the same. So even if the same prompt was given, you might get different results again and again. That is a fundamental problem, and then you also have to handle hallucinations and all that. So that's why having a proper evaluation score helps here. Yeah, so this is like a classic problem that we have. If you change like one prompt sentence or one prompt word itself, you could get these two results. Um, Even without the prompt change, there are multitude of reasons why you could have these two results for the same prompt even. Yeah, so this is the tale of two teams. I've been in both teams. I mean, our team transitioned from team A to team B. So at the start, we had no evals. We ship a change in our AA agent pipeline, and then users will complain about something. So I was in both of these teams, one with no evals and one with evals. Uh, the team with no evals, like we start shipping a change and then the users complain. But since it is an LLM pipeline that you are handling, you won't be able to reproduce it manually that you can with a deterministic code. So what happens is you try to fix the bug, and in doing so, you might break another thing, another sort of workflow. Since you don't have any evaluation number, evaluation metric, what happens is that you keep going through this loop wherein you ship inconfidently. Um, Compare that with the team with evals. What happens is that you make a change, you then run the evaluation suite rather than doing manual spot checks. And what the evaluation suite gives you is it gives you a score. And with that score, you will be able to confidently ship because all the stakeholders across the team can see what the score is and how much or how it has differed. And that lets you ship with confidence. And any new failures that you might encounter in production systems becomes your new test cases, and these test cases prevent rejections. So you will be able to adopt new models whenever they come on the market. And metrics obviously is a great tool for you to talk with your stakeholders. Yeah. Yeah, so like I told, LLMs are stochastic and they produce the same different outputs even with the same prompts. So you can't really rely on manual spot checking. So tiny prompt changes will also lead to big output shifts. You need a way to detect this. Uh, there's one more problem that is quite unique to LLM pipelines is that your provider could have degradations and you might not catch them unless you have good monitoring, real-time monitoring system. And yeah, so we'll get into the demo agent here. We'll today build an AI translation pipeline. So this is what we'll be building. We will have three agents, and two of them are LLM agents, and the deterministic formatter is just code. We'll be using LangChain and LangSmith for the observability, and LangChain supports all these types of agents. Um, so the first agent is a translator agent. This is your straightforward translator agent wherein you can give an input and it spits out the translated text in your target language. But translation is not a straightforward problem. There's all sorts of ambiguity in the sentences that you can give. For example, let's say he went to the bank, could be a statement. And what happens there is that that sentence may not be, may translate into two different things. Either he went to the financial institution or he went to a river bank. Depending on your language, your target language, there could be much more ambiguity in that. So we have an agent to detect ambiguity here. That is also an LLM agent, which takes in the input text and says whether the input could be ambiguous or not. And then finally, we have the deterministic formatter. It's just code. It cleans up the code's white space and any structural formatting here. The reason why I'm stressing on this deterministic formatter is that not everything in your AI pipeline needs to be through an LLM. Anything that you can do deterministically, you need to do deterministically. Um, yeah. So one note on this: this is a very rudimentary generic LLM translation pipeline. We have much better specialized tools to do this, but this is only a toy problem to demonstrate our agent eval patterns. Maybe I can give a few sentences that you can check, right? I'll put them up on the poll. Yeah, so we went through this. What do you think? Is this ambiguous or not? Give me a match. Is that sentence ambiguous in whatever language that you're trying to translate into? Yeah, so yeah, it is an ambiguous sentence. I see a few responses, and yeah, give me a match could translate into either a game or it could mean a matchstick or something. So we have a lot of these ambiguous sentences, and our AI pipeline needs to also handle this. Um, so yeah, we'll get into the code for this. So we will be using Google's GenAI models today, and you can go to the GCP console and then sign up for a new account. I guess you get $100 or $200 of free credits for you to play with. So I suggest you, if you want to try this, you can go and use that trial. And so this is our model manager, and what we do is we initiate this Google generative AI code here, and then we give the Google API that we got from GCP. Um, so this model manager is what we'll be using throughout this code. And now we have the code for the translator agent. If you look at this, this is a class that tells you what the output should look like. This is one of my favorite features of LangChain, and we use Pydantic to tell how the output should look like. There are structured outputs in recent LLM providers, like OpenAI has structured outputs. But for you to work with any model, LangChain gives you this Pydantic model so that you can tell the LLM to how exactly to parse the output rather than like fiddling with getting the exact structure that you want. So we want the raw translated text from the LLM as an output. So we specify the field and we give the description, the exact translated text without additional information. So that will be our primary translation output from this agent. And so this is our code for the translated agent itself. So we have a prompt template. We have system prompt saying you are an export translator. And then we pass on the output language, input language, and whatever context that a user could provide. For example, when we looked at the previous ambiguous sentences, those sentences could be translated properly when there is additional context. So in case we have that, we can get that through the user. But what we expect from our pipeline is that if there is no additional context, we wanted to, sort of say that, oh, this is ambiguous. So that's what we'll be looking at the next. So we invoke the prompt template here and translate. We'll come back to this. We look at our ambiguity detector. Again, this is also a pydantic model, and we are trying to tell the LLM how exactly we need the output parsed. So we need an ambiguity report, and the report needs two things. One is the signal. The signal could be red, yellow, or green, and what the signal says about our translation is that, is the text ambiguous or not? If it is like unambiguous at all, then we say the signal should be green. If it is clearly ambiguous, then we ask the LLM to report red. And if it's a maybe, then we ask the LLM to print out yellow. And also the second field here is, if there's a if the signal is not green, if it is ambiguous in some sort of way, we ask the LLM to explain why and how to improve, like how exactly to get more context, or what context it could have to improve this translation, right? Yeah, so again, we have a system prompt and a user prompt that takes in the input language, the original text, and whatever text was translated, and we pass all of this on to the ambiguity detector, and it spits out the report for us. And finally, we have this deterministic formatter. So this is just straight up code. Here we only like remove the white spaces and do some raw formatting here. Yeah, so this is where LangGraphs actually thrive, in my opinion. LangGraphs lets you build out a graph of all these agents. So if you want, you can have loops, you can have conditionals, anything that you can think of in a flowchart, right? Um, so it's very helpful if you want to, retry a couple of things, specified number of times. But uh, in our today's example, we'll only do like a straightforward example. So we have a start node, and from start, we pass the inputs to the translator agent, and the inputs and the output of the translator agent will be passed on to the ambiguity detector. And finally, we pass it on to the formatter, and we have a rent. But if needed, we can like loop more additional context, and then we can ask the translator agent to rebuild our translation with that additional context. But yes, so we have built a pipeline here with our code. How do we actually evaluate if it's good or not? Right? If your instinct is to, test out a few inputs that you already know, then I guess you're right. So we'll do that. Yeah, so I have these few examples. If you want, maybe throw an example in the chat. But these are the few examples that I have. So we have the first input here is the actual text that we want to translate. And the second one is the language that we want to translate it into. And the third is additional context that the user may have provided. So present here is an ambiguous word. It could either mean giving a present, or it could mean that your presenting is clean. With this additional context, it should translate it properly to the target language as gifting. But bank here is also an ambiguous word. It could either mean the financial institution, or it could mean a river bank, right? So this should, give us the signal as yellow, and it should give us an additional translator from the LLM for us to improve it, right? So we'll run this.
Hey, Raj, sorry for the interruption. Can you please zoom in your screen so that things will be visible more clearly?
Yeah, yeah. Can you
Yeah,
see it now? That
yeah,
clear?
it's
Yeah.
better now. Yeah, thank you.
Cool. Yeah. So we have this. So we have all of these inputs running, and if we look at the first one here, it should say the ambiguity report is green. Um, and it has translated it properly. If you know Tamil, it's called Parisu here. And the ambiguity report correctly predicts that, oh, it is green, right? Um, and then if you look at it for the second sentence, bank, it is a polysemous word. Bank would mean a body of water or it could mean a financial institution. And if the ambiguity report here is correctly says that it is yellow. I will open this up in a different screen so that you can look at it properly. But yeah, our initial test results are that our agent is able to predict whether the given sentence is ambiguous or not. And it is also giving us a good translation, right? So we know this. We know the outputs for these first inputs that we gave. But how do you go from here? Probably when you are developing, what you'll do is you might have a few examples that you know or your immediate peers would know. But what we really need is for our whole team to take a look at it, or even our subject matter experts to take a look at it, right? Um, so how do we do that? This doesn't scale because you won't be able to share this result. You won't be able to, manually copy paste this every time you run a new input. So that's where LangSmith comes in. So we'll move on to observability here. LangSmith lets you, share all of these with your team, and that's where we'll start. Um, LangSmith also gives you other superpowers. We'll see all of that. You don't need to, sprinkle print or log statements across each of your agents. Um, and if you are using LangChain and LangGraph, the setup for LangSmith is very simple. You just need to add on, go on to smith.langsmith.com and then sign up for an account, and you can have an API key in as little as 5 minutes. And you bring that API key on and you put this in your .env, and that's it. That's the whole setup. You don't need to add in any more code if you're using LangChain. LangSmith is sort of platform agnostic. If you're using something else, if you're like directly calling the APIs, you may still be able to use LangSmith. But today we'll be looking at LangChain and LangSmith together. With that setup, the setup that you need to do is minimal. We have the setup in our project, and let's now go into what we actually traced here. So these are the outputs that we, saw, inputs that we ran right now. If you look at it, it's like 835. So we have the input, we have the output, and we know how much each of the calls took, what cost it took to run each output, how many tokens were consumed. You get all of this in just with that .env inclusion. You don't need to write any more code there. And if I click on one of these, you'll see the traces here. You will see, there's a translator agent, and the what model it exactly called and what the A exactly gave it back, right? You can look at each and every step and trace where it went wrong or where you may need to debug this. So this is an excellent tool for you to debug. Um, Even before we come to the evaluation part, this is an excellent tool for you to have in your AI development toolkit, right? So let's say you see this, but you also want your team to, take a look at this. So what we can do is, select these and we can add this to an annotation queue. So annotation queues are for your team, right? When you So we have selected this queue, and what it lets you do is you can add a feedback rubric, and you can ask the team to vote on whether or not this is correct, is this ambiguous, and all that. Um, this is a very easy way for you to gather feedback from all of your team. Um, we already have a queue here. Maybe I'll show that. Yeah. So your team then comes, takes a look at this. This is what your screen will, your team will see, and they'll see what the original text was or the output language was and what the output gave, right? If say this should have been green, but this was yellow, your team can mark this as yellow and then give some reviewer notes. This gives you like a good feedback loop that you can come back and take a look at and try and debug based on subject matter experts rather than taking your own call, right? Yeah. We'll go back to our. Yeah. So once you do this, you will have a very basic pipeline that works most of the time. Um, but you are still not at the evaluation step. You still don't have a data set for you to rely on. Um, Bigger data is what gives you confidence, and what lets you track metrics and all. We ran for 7 inputs, and 7 inputs may not be enough. Depending on your use case, you might need hundreds or even thousands of inputs for you to have a proper evaluation pipeline. So we have, I have prepared like a small data set of 100 inputs. Just a second, I'll zoom this in. Yeah, so I have 100 sentences, small sentences. I have curated this so that there are things that are, ambiguous, things like, mm, look at that fly. So it could either be a zip or it could be uh, an insect, right? So we have prepared this data set. Ideally, what should happen is that your stakeholders should come together and talk with subject matter experts, and that's how you will prepare this data set. The ideal number of rows for your own use case will differ. Um, but for now, we'll make do with this 100 rows. So it takes a while to get through that. So I've imported this into our LangSmith pipeline, LangSmith platform. So we have our input, we have our reference outputs, and if you want, you can split this in any manner you want. If you have done any sort of machine learning things, you would split your data set into training data set and yeah, so you can do that. But for now, we only have our base data set and we will use all of that to evaluate our pipeline. So let's evaluate. And we have three types of evaluators. The first one is human evaluation. We already saw this with our annotation queues. You let your team or your stakeholders annotate and review your outputs. But as you may know, this is going to be very, very slow, and it is not going to be scalable. So we will look at other evaluators. The first is LLM as judges. So what we are trying to do here is we are trying to use the expertise of an LLM and sort of substituting that for a human here. It's not going to be 100% correct, but it should be good enough for most use cases, right? For our own pipeline, we are going to write a correctness evaluator. And the next type of evaluator we have is a code-based evaluator. Code-based evaluators are just deterministic. They don't have any sort of intelligence to them in the sense of an LLM or a human. They are going to be very rule based. Things like if the output isn't there or not, if there is no extra white space, those are things that you can handle deterministically, and that's what we'll use a code based evaluator for. Right. So our first evaluator is a correctness evaluator. Whatever output that we get from our LLM, we want to know if it is correct or not, right? So maybe I'll show that in the code. So this is our correctness evaluator function. So what we are doing is we have a system prompt and which has a huge system prompt. We are asking it to compare the reference output that we already have in our data set and the actual output of the LLM. So our LLM as a judge should be able to judge both of these and give it a score. Whether the given output, the LLM generated output matches the reference output that we have from our data set, right? So we will run that, and we'll also look at the code evaluator and we'll see the results together. So the code evaluator is trying to check whether there is a translator comment or not. Whenever our pipeline returns yellow or red as our ambiguity report, we also want a translator comment so that to accompany it so that we can improve the translation in the future. So our code-based evaluator checks whether there is a translator comment present whenever we have a translator comment present in the reference output, right? Yeah. So how do we run this evaluation? We already imported this data set into LangSmith. We can just copy this ID and we can come back to our evaluator code. And so we have these two functions, is correct and matches translator comment. Those are our two evaluators. And we can pass the data set here, data set ID here, and we ask the LangSmith client to evaluate. That very simple thing here. You can tweak with the concurrency parameters to make it a bit faster, but this is going to be our pipeline. So the target here is the actual invocation of the translator, the whole translator pipeline. The outputs of this translate invocation will be passed on to our evaluator. Right? It will maybe, yeah. So the evaluation takes a bit of time. So I'm going to be showing up the actual output that it generated here. So we have 100 rows here. And we also have score for all of this, for each of these rows. And so the is correct evaluator would have evaluated each and every row. We can maybe take a look at this one. And if you look at the reasoning, this is our LLM as judge evaluator, if you remember it. Because it is an LLM as judge evaluator, it also provides the actual reasoning for why it thinks it is correct. So the provided translation is identical to the reference translation, capturing all of that. So the score should be true, and we have a 1 year. But if you look at the next one, it says the correctness evaluator gave a score of 0. And if you know Tamil, the reference output and the actual output are different here, which means our evaluator evaluated it correctly and said the score is false, right? The reference output is meaning the date as the fruit, but the actual output from the LLM gave date as the calendar date. So that's why it has given a score of wrong. So if you read through this, you will see why it reasoned out like that. We'll also look at your translator comment. This is a code evaluator. And if we click through this, so if I click through this, this is straightforward translation, which means there is no ambiguity and there should not have been any translator comment here, right? But our LLM has given a translator comment, further confusing the next translator. So this should have a score of 0 for matching translator score, right? Yeah. So you can go through other examples, but our evaluator has done its job. And we also have a composite score for all of this. So what the composite evaluator does is it takes on both of these evaluations and then assigns a weighting to it. For us, for this particular problem, we want our correctness evaluator to have more weightage. So we assign like 70% of our score to the correctness evaluator, and the translator comment presence is, it has less weightage, so we give 30%. You can tweak with this number to make it more agreeable or break it more often, but we'll just go with this example for now. So this is our composite score. What it has done is it has given 70% weightage to the correctness score and 30% weightage to the translator comment score. So our average score at the end, average composite score at the end is 0.87, right? So this is your baseline score that you can use to ship further. So we also have now we can like run other experiments now that you have a composite score that you can rely on. So you can change to a worse model to see if the performance is still there, even if you switch to a worse model. You can also change some prompts to see if the score improves. So we have done quite that. Maybe I'll show that. So what we have done in this particular change is that we have added a bit more sentencing here we have tweaked the system prompt for the translator agent. We have said, oh, if there are polite imperatives, keep it as is, right? I will maybe, so this is our baseline evaluation. So this is one of the examples that failed. If you look at it, it has said அவர் ஒரு marathon ஓடினார் versus அவன். This is basically polite versus impolite. Our reference output is expecting a polite pronoun, but our actual output is giving an impolite pronoun. We want to punish this, and our evaluator has correctly punished this. But after our change to like keep the polite imperatives, we'll see if it has improved or not. So this is the output. This is the evaluation after we have made the change there. And if we come back here, now our pipeline has like stuck to the correct polite pronoun. And now our score is 1. And if you look at the composite score after this change, earlier it used to be 0.87, if I'm right. Now it has improved to 0.92, which means that our change is working correctly. Our prompt change is not actively making things worse. And this is a good change that you can ship with confidence, right? Now we'll look to, change or swap our model with a worse agent. Right? So this is essentially the change that we have done here. We have changed from Gemini 3.1 to 2.5 in both the translator and the ambiguity detector. And if you look at the results for that, our score here has dipped 0.89. It has come down to from 0.92. Yeah, so this is our first change. This is our baseline change. And this was after we have improved the system prompt. And after we have improved it, we have gone back to worse models. And the score has dipped, but when you compare it to the baseline, it has improved. So you can evaluate all of that with this evaluation pipeline, and your composite score is going to be the score that your team is going to take a look at and your team is going to rely on. LangSmith also gives you like much more things here. You can look at the P50 latency, you can look at the P99 latency. If there's any errors, it'll surface it here. Yeah, so this is fine. Even with our changes, these are fine, right? Okay, we'll come to online evaluation. We'll just take a quick look at it. All of these things that you have done is part of the development life cycle. It's not in real time. It's not in production. It is going to be before you ship. Online evaluation is going to be for production pipelines. For example, you want to monitor your pipeline in production for prompt injection and such. You can use evaluators and online evaluators particularly. And one such evaluator I've given here is that I want to see whether there's any prompt injection that goes on in my online traces. So this is a big prompt, but essentially what it tells is if somebody is trying to manipulate my agent into giving out information that it is not supposed to, then I want it to be flagged. So when you run the this pipeline with LangSmith enabled in your production, you will also get these traces even for your production things. And if you look at this, we have our feedback, and it says, oh, there's no prompt injection in any of these prompts. Prompt injection score is 0. So that will be your online evaluator. You can use it for much more. I'll just give you a quick example. You have these many templates for you to take on. So that's our online evaluation. There are some differences on what you can do with offline and online. Offline, you can run against a reference output. Online, you'll only be able to use whatever output was generated. And you can also only enable it for a certain percentage of your online traces rather than doing it for 100% of all your user queries. Yeah, with that, we sort of come to our conclusion. LLMs are stochastic, and that's one of the main reasons why you need automated evals, and a particular score that you can rely on. And LangSmith gives you this observability for zero code changes. And there are other platforms out there that are more cheaper. I think MLflow is one of them. But LangSmith is easy to start with if you're already in the LangChain ecosystem. And make use of all the evaluator types. Use your human intelligence, use LLMs as judges, and take on a composite evaluation score that you can give to your stakeholders. So yeah, that's it. If you have any questions, I'll be happy to take them.
So yes, folks, Q&A panel is open now. You can drop your questions. So if Raj can address it. Also, Raj, can you please share the screen and show that QR code, feedback
Yeah,
QR code?
yeah,
Yeah.
yeah. I'll give the code repository. Let me see if I can share that now. So that's the repository, and I guess the latest code will be in a branch called demo, which I'll make it. Um, yeah.
Any other
Any
questions,
other
folks?
questions?
Yeah. Can you please share the code, Yuvraj, QR code?
Yes.
So, folks, even not now, if you're having any questions, you can scan it and you can share your questions and feedbacks using this code.
Yeah.
So,
Thanks so much. To let me know if you have any questions, you can reach out to me on LinkedIn. If you have any questions even after this, I'll be happy to help out.
yeah.
I didn't
So,
understand your yeah take
uh,
on Chandra.
yeah. So, Vlad, I have asked how can I connect new meetings. So, please follow our LinkedIn page, RailsFactory's LinkedIn page. So, we'll update about our upcoming webinars there. Thank you so much for showing interest. So, I guess we can close the session now. Thank you, everyone. Hope you found it useful. Thank you, Viraj. Thanks for your time. Yeah. Thanks, folks.
Thanks everyone.